Right. We'll spend some time on engineering economics today. Not a lot. Historically, this topic, engineering economics, it's not that has been, heavily asked on. You can probably expect one or two questions on this, but it's important as well. So we'll start off with that, and then we'll, get into the technical side of the things. What is engineering economics and why does it matter, right? If you think of it, uh, other than learning the technical aspect of what we do engineering, it's also important to know how the business side of the things work, and especially in this day and age. But we every company that we work for or that operates is looking to make profit. So there has to be a way that before choosing a project or rejecting a project, there should be a way that some sort of analysis is done to be able to determine whether a particular project is going to be profitable or not. So there are some tools and methods that help us do that. So as far as the PE exam goes, there are quite a few formulas, that we should probably familiarize yourself with in order to be able to answer these questions. And the good news is that correctly solving these economic questions that appear on the exam tend to be very easy once you understand how to set up the formulas to solve what the question is asking for. And it kind of gets tricky in that there are quite a lot of formulas, even now if you look at the handbook. So in order to figure out which one to use can be tricky if you don't know what exactly the problem is asking for, and they kind of seem very similar. So that's why it's important to have a solid understanding on the cash flow diagrams, which is what you see here. Basically, is Israel is asking what page are you on? Um, so this is the first page, or yeah, the first page of the refresher notes, Israel. This is the refresher notes that you have access to on the dashboard. So I was talking about the cash flow diagrams. So this is an example of a cash flow diagram. So it's nothing but a graphical representation that shows, how the cost is being spent based on a timeline. For example, in this particular example that's given here, it says that there is a generation project which is being in the talks whether they should a particular company, utility company, should invest or not. So they this generation project requires $21 million to get started, for the commissioning and construction costs, whatnot. And then for the course of 25 years, this particular project is going to generate a cash flow, an annual cash flow of $2 million every year. So you see the above arrow marks, which means there's a positive cash flow for starting from year 1 through year 25. And then it says that towards the end of the year 25, there is a decommissioning cost of $5 million, which the company has to spend in order to retire this plant. So that's another $5 million that they have to spend after what the $21 million that they spend right now. So as a company, as a utility, they're trying to figure out whether it's a good investment or not. So how do we do that? Because the biggest thing here is the value of money today is better than, for example, I would say if you have $100 today, that's better than $100 next week. That's how the value of money degrades.